Hey there, thanks for checking out Talk Tech with Beck. If you remember last week, I talked about JavaScript functions and went over one way to go about defining one. If you're not sure what a function is, head over there first. Link's going to be right here. Then come on back to learn even more about functions. If you're feeling good about what they are, then let's keep on going. And you can go check last week's video next if you haven't seen it yet. Today, we're going to keep moving on into the world of functions, and we're going to talk a little bit more about bindings and also bring in scope. And of course, we're still going to refer to the excellent book, Eloquent JavaScript, as we go. Let's start with bindings and scope. We briefly breezed by bindings last week, but now we're going to go a little bit more in depth. From our book, each binding has a scope, which is part of the program in which the binding is visible. For bindings defined outside of any function or block, the scope is the whole program. You can refer to such bindings wherever you want. These are called global. But bindings created for function parameters or declared inside a function can be referenced only in that function, so they're known as local bindings. Every time the function is called, new instances of these bindings are created. This provides some isolation between functions. Each function call acts in its own little world, its local environment, and can often be understood without knowing a lot about what's going on in the global environment. This is why, when working on something like algorithm practice, something more generic, you are able to use the same variable in two different functions and call both functions without receiving errors. In this example, there are two different algorithms to solve the same problem. When given an argument of n, as an integer, add up every number between 0 and n to get your total. Both functions use n as the parameter, but since each function is performing its own local task, there is no conflict. Now, if I were to also, you see, when I go ahead and run those console logs, we get 55. Both of them solve the problem the same. If I put a different number in for n on one of them, we will still get our answers. So if I were to also put in here a console log just to see what n is, what do you think is going to happen? I think, yep, there we go. We have an error, and that error is a reference error because n is not defined. What do you mean n is not defined? It's right here. It's right here, but it's not outside of those. It's only defined locally, which means outside. This n doesn't exist. It's not defined globally. So what about, let's go ahead and we can declare n. So let's say let n equal 93. And then go ahead and get that clear so we can see what we're doing. We go ahead and we'll run those console logs again, and we do. We get a 55, a 91, and a 93. But if we've declared n, why doesn't that n then affect our add up to? It doesn't affect it because, again, n is global, but it's also local, so that global is not going to override that local. If we declare n globally, then we'll get a return for our third console log, but the global declaration won't pass into our local declarations. So say we were going to console log this and we didn't pass anything in for n, in the hopes that without an argument, maybe our global n would take over. Nope. We get 0, we get not a number, and we get our let n equal 93. The reason we get 0 for that first one is because we are returning our total, which we've declared as 0. And since we don't have an input, there's no I. I is never less than or equal to n because there is no n. So we can never total plus I, so we just get our 0. And then over here, we don't have a number, so we just get not a number. So that problem also goes hand in hand with scoping. A scope is usually able to look out into the scope around it, above it, in the hierarchy, but there is the exception, and that's when multiple bindings have the same name. When that happens, code only sees the innermost one, which is why both add up to and add up to again will look towards their own n instead of inheriting the globally declared n. Got that? Let's do one more quick example where we're more clearly declaring our variables and can see what is available globally and locally. So let's go. We will say let x equal 10 equal 10. So this is our global binding as it's declared outside of any sort of block or function. So we're going to say if true, we're going to let y equals 20. Then we're going to use var. Var is, var is old. Var is pre-JavaScript 2015, and it's not really used anymore. You're not going to see it taught very in depth, but you will find it in some legacy code and also in some older training, so it's nice to have like a little bit of an idea about it. But basically, pre-2015 JavaScript bindings created with the var keyword are available throughout the whole function they appear in, or if they don't appear in a function, then they are available globally. Like in this example, because if true is not a function, just a block of code. So inside of here, we will go ahead and console log x plus y plus z. And then we can go ahead and we can run node function video 2. And we will get our console log of 60. We've got 10 plus 20 is 30 plus 30 is 60. So then if we wanted to go out here, we can console log x plus z. We run that again because we'll see we get 40. And let's see, according to what we've been talking about, that y should not be available outside because it is declared locally inside that block of code. So we should get ourselves a nice little error, and we do. And right here, it's very clear. It gives us a nice little error that says, hey, that y, we get a reference error, y is not defined, which is exactly what we expected. So now that we all feel a bit more knowledgeable about bindings and scope, let's talk about functions as values. To quote eloquent JavaScript, a function binding usually just acts as a name for a specific piece of the program. Such a binding is defined once and never changed. This makes it easy to confuse the function and its name. But the two are different. A function value can do all the things that other values can do. You can use it in arbitrary expressions, not just call it. It is possible to store a function value in a new binding, pass it as an argument to a function, and so on. Similarly, a binding that holds a function is still just a regular binding and can, if not constant, be assigned a new value, like so. So we'll do another little example. So we would say, let launch some missiles. It's going to equal not a gunction, because a gunction's not a thing, but a function sure is. I'll say missile system, because if we're launching missiles, of course we have a missile system, and we definitely have a launch command. So now, and then we'll end that. But like any good missile system, we would have a safe mode. So if we are in that safe mode, then launch missiles equals function, and basically what that function means is do nothing. Do nothing. Pretty straightforward, yeah? No. This does look pretty similar to what we did last week. The main difference here is which keyword we're using to declare our function. Last week we used const. The value of a const variable may change, but it cannot be redeclared. Lots of people say that const is immutable. It's not, because the value can change, but its declaration is immutable. Once it's declared, it will be that. It will be that forever. It cannot be redeclared. But if we're using let, then we can declare a function as a value, one that can be changed and are declared when, if, or as needed. Functions as values allows for some neat flexibility and adaptation in your programming, which you'll learn more and be able to do more as you progress and practice. Passing around function values to other functions can be pretty interesting, and perhaps we'll get to some of that in a future video. So that's kind of it for today. We did a lot about, binding and scope, but that's really important when you're learning how to manage your functions and move them around and make things work. It's pretty fun. So we're moving and shaking in our JavaScript fundamentals. We have a few more things to talk about when it comes to writing functions. So come back next week for more Talk Tech with Beck, and don't forget to like and subscribe so you'll get some notifications when I post new videos, which will usually be on a Sunday night / early Monday is when you'll probably want to watch it. So thanks again, and I'll see you next week for more Talk Tech with Beck. Bye-bye.